Well, dear students, I come here to another topic that is electron volt. Though we have learnt too much about electron volt, but again I am revising because it will be used very frequently in studying the nucleus. So, electron volt is a small unit of energy. We have used it in measuring the energy of photons, electrons. Then how much energy is one electron volt? The kinetic energy gained by an electron when accelerated, when it is accelerated by a potential difference of 1 volt. 1 volt. If suppose here there are 2 points, negative, positive, and there is 1 volt potential. If we leave electron, it will accelerate this way. So 1 eV is equal to charge over electron 1.6 × 10⁻19 coulomb into 1 volt. Coulomb into volt is equal to joule. So it is 1.6 × 10⁻19 joule. You have seen while learning physics, electron volt actually is a really very small unit. So we use here another unit, bigger unit than electron volt, just to express the energy of possessed by nuclei and particles of the size of nucleus. 1 million. Some people call it as mega also. 1 million electron volt. Million electron volt. Million electron volt. Represent 1 M, capital M, small e, capital B, 1 MeV, means 10⁶ eV. 10⁶ electron is equal to 1.6 × 10⁻19 into 10⁶ joule. Or we write as 1.6 × 10⁻13 joule. 1 MeV is a bigger unit used to measure the energy possessed by nuclei, different nuclei and other particles. Even the energy of photon, X-ray photon, you have learned, is measured in million electron volt. Because then we have, we use only electron volt, then we have to use big number. So to avoid that, we use this thing. Now, in the early time, the mass and energy were different physical quantity, but Einstein proved that mass is also form energy. So relation between between 1U and MeV. According to Einstein, mass and energy are equivalent to each other. Mass and energy are equivalent to each other, and the two are related to each other by equation E equal to mc square. Sometimes question come on this equation where capital E is the energy equivalent to mass m. So we can obtain energy equivalent to 1 AMU. To obtain energy equivalent to 1U, we use 1U as 1.6605 into 10 to the power minus 27 kg and C equal to 3 into 10 to the power 8 meter per second. In equation E equal to mc square. So we get here E equal to 1.6605 10 to the power minus 27 into 3 into 10 to the power 8 square. It will come out in joule. This value will come out in joule. Now if we convert that into MeV, so it is 1.6605 into 9 into 10 to the power 16. 8 square 16, 27, 16 minus, so it is 1 and 1 minus 11 joule. Convert that into MeV. 1.6 10 to the power minus 13. So if you multiply 9 5 are 45, 9 6 are 54, 5 9 6 are 54, 5 59. Sorry, क्या हो गया? 9 6 are 45, 4 9 are 54, 5 9 are 54, 5 59, 14. Decimal after 1 2 3 4, 1 2 3 4 upon 1.6 10 to the power 2 MeV. Dear friend, whatever data is given, we have to use that here in calculating this. But when we divide this, listen here, it is 149.445 divided by 16. 16 9 ja 144. 5.4. 3 ja 48. 6 4. 16 4 ja 64. And then 0 like this. So we get it here. There are two, so we get it nearly 934 MeV. But 34 MeV. But when we use more precise values of C and M, actually speed of light we have taken 3 × 10⁸ meter per second. But practically it is found in 2.98 something into 10⁸. So when we use this, so I say here, but the standard relation between U and MeV is it is actually 1 U is equal to 931.5 MeV. So till now I have told you about simple idea of nucleus. Then I told you definition of one atom mass unit, and again I repeated the concept of mole. And here I defined 1 electron volt and then 1 MeV, and then finally I obtained relation here 1 U equal to 931.5 MeV. Dear student, remember I am not writing here a textbook. I am helping you to understand point wise. Now I told you isotopes. Isotopes are the elements of same element having different masses. For example, hydrogen has 3, carbon has 2, 6C12, 6C14, chlorine has 2, almost every element has. Now here the mass number is 12 exactly. 14, or we write 27Fe56. Here 27 atom number, this is mass number. If this is X element and we write Z here and A here, या कुछ लोग ऐसे लिखते हैं, NCERT will write like this. Z is atom number, A is mass number. So mass number is sum of the mass of proton and neutron inside nucleus. I will be telling you how the nucleus was obtained. Then why masses of nucleus and atom mass is in fraction? For example, atomic mass of, just I told you, 6C12, in U that is written as chlorine के लिए 35.47 atomic mass of carbon is taken as 35.47 U. Why fraction is there? Many reasons are there. One reason is that atomic mass of every element is the average of the masses of its isotopes. Here one example given, chlorine has 2 isotopes whose masses are 34.98 34.98 and 36.98. These are the atom mass of 2 and their abundance, in what ratio they are found in nature, is 75.4% and 24.6%. तो एवरेज एटम मास जो होगा that will be average of these. So this presence in nature is 35.4 into नहीं यार sorry 75.4 sorry बोला तो इधर into 34.98 plus the abundance means presence. The other presence is 24.6 acetate out of 100 into 36.98. In natural occurring chlorine, if we take 100 isotopes, 24.6 isotope atoms have mass this, 74.5 has mass this. So what is atomic mass of carbon? So chlorine. So atomic mass of chlorine equal to this plus this upon 100. And when we solve it, we get nearly 35.47. U. So atomic mass of every element is the average atomic mass of its isotope found in nature. Secondly, when nucleus is formed, I will be telling you later on, when a nucleus is formed, some mass is lost in the form of energy, which is called binding energy, and the difference of mass defect. So due to that, though we write here mass number like this, तो वो हमारा एवरेज एटॉमिक मास है. तो आई टोल्ड यू दैट इन केस ऑफ 1h1 the simple problem was there, okay, 1 proton 1 electron, but when discovery of isotope took place, hydrogen was found to have 2 more atoms which have mass twice and thrice of this. Then what is inside nucleus? So initially it was supposed that electrons are there, but concept of presence of electron was rejected due to the theory of given by Heisenberg uncertainty principle. That theory says that electron cannot remain in a size in the space which is the size of nucleus. It needs much larger size to live. So discovery of neutron I will be telling in next video. Discovery of neutron. Electron was discovered in 1897-98, and then Bohr theory was given in 1911, and neutron was discovered in 1932, very late. For so many years it was a problem with people that what is inside nucleus more than proton. By electron cannot be there, so what is that mass? So that mass was of neutron. Then how it was discovered I will talk in next video. Thank you.